So by now you should be very familiar with the concept of domain and range and using graphs, table values, and finding the domain and range. Now we're going to be looking at some real world applications where we have more restrictions on our domain and range. And so we're going to be using that similar set notation within these problems to represent our domain and range. So starting with our first example, we are told that a rectangle has a fixed perimeter of 20 units. Let the length be L and the width be W. So our variables are defined for us, and of course we know the perimeter of a rectangle is 2 times the length plus 2 times the width is equal to 20. So now, write an equation for W in terms of L. So we pretty much want something to be W equals something. So we're going to rearrange. So 2W equals 20 minus 2L. And then if we divide by 2 for all terms, we get 10 minus L. Now, what is the domain of possible values for L? So keep in mind, we had a restriction where if we go around this rectangle, so cover the perimeter, it has to be 20 units fixed. So that gives us a restriction here where we see that W equals 10 minus L. So if you're not able to see that right away, consider if I told you the length is equal to 12. So if that were the case, then W would need to be 10 minus 12. But in doing so, W is negative 12, and width cannot be a negative value. We need W to be not even greater than or equal to 0, because if it's a width of 0, then that's not a rectangle. It's just a straight line. So we need it to be greater than 0. So this does not hold true. So essentially, um, we look at here this equation, and we see that if L is equal to 10, then W is 0. So we also can't have that. So L is equal to 10 gives me W 0. And we saw that any value of L greater than this will give us a negative value. So we need L to be less than 10. But what if I told you L is, let's say, negative 20? In that case, you would have width as 10 plus 20 is equal to 30. And that would also not hold true. And I now realize my own error, and I hope you caught me on this, but I can't even tell you that because length cannot be a negative number. So similar to the restriction we have on W, because we are working with measurements, this also has to be greater than 0. So for our possible values of L, we have 0, L between 0 and 10 exclusive, which means we are not including 0 and 10 itself. So now, just an analysis of that domain word there. So here we have a equation for L written as W. So here I can pick any value of L between 0 and 10 as my independent variable, and W will depend on whatever I chose for L. So that's why I use domain here. In other words, I'm just asking you the possible values for L, but in set notation. So we would just write it as L belonging to the set of real numbers with our restriction that L is between 0 and 10. And that would be the correct answer. So please remember, don't leave it just there. We want that set notation to tell me that L can be in the set of real numbers as well. So now let's look at another example, now this time finance. So here we are told that our investment is modeled by the following equation where T is in years and 8 is my investment amount in dollars. So we're asked the domain and range for this function if I want to keep the investment for up to 10 years. So T could be any uh, value in terms of like years. I could have 10 years, I could have 50 years, 100 years. Sure. But again, as we learned last time, we are giving meaning to these based on the word problem. So if I am told that I want to keep this investment for up to 10 years, then if I am starting at time now, t is zero. Oh, t is zero would be now, and I'm going up to 10 years, then I am considering the range of t in the real numbers, and t is going to be between 0 and 10 inclusive. So for up to 10 years. Now, based on that, try to think what the range could be. So one way would be if you just graph this and found it using the graph, but I'll show you how to find this mathematically as well. And specifically, I'm going to start with that inequality I have here. And I'm going to try to recreate this equation using operations to t. So first I see t here is being multiplied by 150. So I'm going to multiply all through this inequality by 150. And an inequality works similar to a equal sign in terms of distributing, for example, a positive multiplication. So in this case, it holds true. It doesn't hold true when you multiply by a negative number. We do have to switch over the greater than signs to less than signs. So just switch them over. Um, we don't have that in this example, so it's a little easier. And now I want to add that 1000 as well. So I'm gonna get, actually maybe let me just write it. This will be plus 1000, and then this will be 2500, and this will be 1150. So then within this context, our range, so this was domain, my range would be A of t is in the set of real numbers, and this holds for 1150 in, and between 2500 inclusive. And that would be my domain and range. And so interpret the meaning of the range in this context. For that, remember A of t was my investment. So that means that after 10 years, based on my investment, I can expect to have at the maximum range 2,500. And at my minimum amount or my starting point when t is 0, I am starting with $1,150. So I would expect a growth of 1,250 over 10 years. And that would be just your interpretation. You would just write that with words to show your thinking, making connections to the problem with respect to finance and investment. Now let's look at another example, now this time with physics and more falling objects. So here, a ball is dropped from a height of 80 meters, and its height in meters is given by h of t, where t is in seconds. So first, we're asked to sketch the graph. So take a moment here. With this though, because you're asked to sketch the graph, you are not using a graphing tool. Keyword here is sketch. Sketch is something you do by hand, so please, whether you are using a table of values or other methods that you know, try to graph this, and then we'll be right back to answer the questions. Okay, so here I have my table of values and approximately my graph. You should be plotting all of these points, but just to show you, it will be looking something like this. And specifically note here that I'm not going through 4 because at time 4, I'm still not at height 0. So I've not reached the ground. So while the graph gives me a really nice estimate here, it's not enough to be able to tell the exact domain and range here. So for the domain, we need to know that um, pretty much the value of t for which the ball is in the air. In other words, we want to find out when h of t is equal to 0. And so actually here we have to use our original equation to set this as 0. That being said, this is a little bit easier here because we just have and something like this. But please here use a calculator to get your answer, or just leave this like this. That will be fine as well. And knowing that t cannot be a negative value, now let's write our domain. So we have t is in the set of real values, but we only care about when the time it of the time in which the ball is in the air. So starting at time 0 and up to and including oh, 80 over 4.9. And I would just leave it as that exact value there. Now for my range is actually a little bit easier here because we care about the height as it starts until it reaches the ground. You already have that the ball is dropped from a height of 80 meters, so we know that the maximum value of h of t is 80. And we care about when it falls to the ground, which is height 0. So here our range was actually a little bit easier, and we had to do a little bit more work for the domain. And your interpretation, again, connected to the height and the time in which the ball is in the air. And that will be your solution for that question. So now some key ideas here. So domain is the set of values for which our function is defined. So with real world problems, we define our function based on context. So for example, when the ball is in the air or when the flare is being shot through the air, or the investments I make over 10 years. And so we want to add those restrictions based on the context. So values that don't make sense are going to be excluded, such as when we say that time less than 0 is inadmissible. Here as well, height being negative is inadmissible to us. We don't care. Once the ball is on the ground, it doesn't go further than that. So that would be our restriction. So for today's practice, we have some extra word problems with some heights and finance, so similar to the ones we've seen. So try answering some of the questions about domain and range and its interpretation. And that's our 2 lesson on domain and range. So I hope you know a lot about domain and range now and how to determine it for different functions. And if you have any questions, again, don't hesitate to reach out, and I'll see you all next class.